If a Tesla tiny house, tentatively priced around an estimated $7 to $8.99, could significantly diminish the majority of common fixed ownership costs, what specific structural innovation allows it to remain stable on so-called free land without needing a traditional, poured foundation? Assuming a foundation is truly unnecessary, could this tiny house be mobile enough that the owner can effortlessly move the dwelling the very moment they desire a fresh environment or change of scenery? If such frequent mobility is genuinely feasible, what sophisticated structural layout enables swift, simple assembly and equally quick disassembly without fundamentally disrupting or altering the familiar interior design and arrangement? When the interior rhythm and comfort remain consistently steady, do sudden shifts in surrounding weather conditions and varied terrain types significantly push operating costs up? Or can those essential costs, such as energy and water, remain remarkably stable over long periods of time? If those critical operating costs can indeed be meticulously controlled and kept low, what silent, unseen orchestration layer manages to keep the power generation, water recycling, ventilation, and other core utilities working in perfect, seamless sync with virtually no need for constant human intervention or tinkering? And finally, if each essential link in this chain of autonomous systems clicks together perfectly, could the concept of truly free land living become a universally accepted, new standard for housing? All of these profound questions and structural secrets will now be carefully unpacked and explained through 7 shocking truths about this tiny house concept, details that Elon Musk himself has seemingly never officially published or widely discussed. But before we begin to peel back and reveal each layer of this innovative design, please take a moment to subscribe to AutoFusion so we can successfully reach our goal of 8,370 subscribers. And remember to activate the notification bell to ensure you don't miss catching the next crucial chapter in this series. The SpaceX-inspired foldable frame to genuinely achieve the goal of flexible, free land living. The Tesla tiny house must start with a fundamental structural frame that is designed to travel right alongside you. You simply park the transport block, and the entire structure gracefully opens up into a full, spacious living volume. When it's finally time to pack up and depart, it neatly folds back down into a single, compact block that is perfectly sized to fit onto a standard flatbed truck for easy moving. This innovative design completely bypasses the need for pouring concrete footings and all traditional fixed-site work, primarily because the home stands firmly on its own robust, internal structural backbone, rather than relying on an external concrete slab foundation. The material selection then becomes paramount, delivering the essential feeling of solidity and safety. A highly practical and smart choice for a tiny house aiming for this level of performance is 6U61 T6 aluminum alloy. This metal is notably lightweight yet possesses exceptional stiffness, boasting a yield strength of approximately 270 megapascals, and an ultimate tensile strength close to 300 MPa. This contrasts sharply with many common structural woods, which often sit only in the tens of megapascals range. This enormous strength gap allows for the use of much slimmer structural members that drastically cut the overall transport weight, yet they still safely carry all required live loads and stresses. The alloy also readily accepts treatments like anodizing or powder coating, which provides long-term corrosion resistance when exposed to the elements outdoors, perfectly aligning with the low-maintenance goal of the Tesla tiny house. However, having good materials is only half the solution. They must be joined in a smart way. Instead of complex, on-site welding or messily pouring concrete, this sophisticated frame uses precision interlock tongues and grooves that are entirely self-locating. The assembly is then firmly secured with only about 8 common, high-grade bolts, such as M10 to M12 sizes, used to clamp the assembly tight. Factory-machined holes ensure that the crew simply places the sections, the interlocks securely hold and distribute the load, and the bolts then lock everything into a single rigid unit. The process of assembly feels remarkably similar to building a very large adult-sized Lego set. For relocation moves, the entire process simply reverses quickly, having a minimal impact on the established interior layout, ensuring the Tesla tiny house can relocate with exceptional speed. Durability over time primarily comes down to managing fatigue spots, especially at the critical folding hinges and the heavily stressed bolted nodes. Robust design detailing carefully rounds all edges, strategically adds washers or backing plates at every bolt hole, and utilizes the proper bolt grades to effectively avoid the formation of stress risers. Crucially, because the interlock geometry inherently shares the structural load across the joint, each individual bolt only carries a small fraction of the total tension. This means the stress is effectively distributed, ensuring the nodes remain healthy and functional over many fold cycles. The final result is a Tesla tiny house that fully preserves its essential mobility without needing frequent, costly part replacement, and critically maintains structural integrity through repeated deploy and stow operations. This keeps the promise of truly free land living both entirely practical and genuinely long-lasting. 2 crew capsule insulation walls. The Tesla tiny house maintains a steady, comfortable internal temperature by intelligently turning every single wall into a lightweight, high-performance sandwich composite that functions as one cohesive thermal system. In this design, two thin, robust steel skins are bonded around a specialized foam core that is tightly packed with nano-sized air cells. The steel forms a tough, externally sealed protective shell, while the foam core effectively interrupts the heat flow at thousands of microscopic pockets. Because the Tesla tiny house uses industrial adhesive and carefully controlled heat to bond these layers, each panel remains stiff, perfectly flat, and highly airtight from the factory line right through to the on-site installation, which translates directly to fewer gaps and fewer thermal surprises. This composite structure delivers impressive performance figures. R-value measures resistance to heat flow, and the Tesla tiny house targets approximately R40. For comparison, many standard wood-framed homes typically sit only around R18 to R22. This means the Tesla tiny house blocks roughly twice the heat transfer. This significant gap translates directly into daily comfort and cost savings. In the summer, the tiny house needs far fewer air conditioning compressor cycles to reliably reach and hold the same set point. In the winter, it retains warmth much longer between heating cycles. In real-world usage, this can potentially cut cooling electricity consumption by roughly 60% compared with thin, leaky wall constructions of a similar size and usage habits, which is precisely the kind of efficiency required for truly off-grid living. Good insulation is about more than just thickness. The Tesla tiny house also actively combats the two major enemies of long-term comfort and energy efficiency. First, a continuous foam core meticulously removes all thermal bridges, the solid paths that would otherwise carry heat straight through the wall structure. Second, dedicated perimeter gaskets and sealants tightly control all air infiltration, which dramatically reduces interior condensation that typically occurs when humid air meets a cold internal surface. By correctly positioning the dew point and ensuring all joints are perfectly sealed, the tiny house keeps its walls dry, protects its interior finishes, and completely avoids the musty odors that are often much more noticeable in compact, enclosed spaces. Finally, the factory production method keeps all servicing remarkably simple. Panels for the Tesla tiny house arrive pre-cut with integrated grooves and secure latches, allowing crews to follow a clean, straightforward assembly sequence. If a repair ever becomes necessary, a single tiny house panel can be carefully removed, the foam core replaced or repaired, and the edges resealed without disturbing the rest of the structure, which preserves the critical R value and ensures maintenance costs remain low year after year. 3 power plant solar roof to enable truly independent, free land living. The home must reliably generate its own energy supply. In the Tesla tiny house, this process begins directly at the roof, where every single roof tile simultaneously performs two functions. It sheds weather and acts as an efficient solar module. The full roof uses Tesla Solar Roof Generation 3 tiles, achieving an impressive efficiency of around 22%. In simple terms, this means that roughly 1/5 of the sunlight falling on each square meter becomes usable electricity. With approximately 20 square meters of total roof area, the daily energy yield can typically land in the 4 to 6 kilowatt-hour Kava range, depending on the geographical location. This is enough power to run lighting, small appliances, fans, and even a compact air conditioning unit. The projected lifespan of the roof is about 30 years, similar to fixed residential solar systems, with the added benefit that these tiles are both the finished exterior material and the quiet, continuous generator working every day. Daytime power generation is not solely for immediate use. It is also crucial for filling the storage capacity needed for nighttime operations. The Tesla tiny house relies on a Powerwall Mini, a smartly scaled-down version of Tesla's standard home battery, offering roughly 10 kW of usable capacity. This is enough to comfortably support a two-person household for about 3 days of conservative use, even during periods of unexpectedly cloudy weather. Lithium iron phosphate's ALFP chemistry is specifically chosen for its high safety profile and low fire risk, with a lifespan of more than 5,000 charge cycles, which easily equals well over a decade of typical daily use. Less reliance on external power grids means true autonomy and the invaluable freedom to relocate virtually anywhere there is sufficient sunlight. Beyond the tiles and the battery storage, the Tesla tiny house utilizes an AI energy orchestrator. This central, intelligent controller constantly reads the solar input levels, the battery's state of charge, and the live demand from all connected devices. When there is a power surplus, it automatically prioritizes charging the battery or briefly running power-hungry loads like the AC at a higher output level. When the solar input fades, it seamlessly draws power from the storage and intelligently trims non-critical circuits. This smart, dynamic dispatch system can cut energy losses by about 15% compared with more typical hybrid systems that follow rigid, fixed switching logic. In practice, this means the owner gets more usable power without needing to increase the panel area or the battery size. 4. Zero foundation floating floor. For a home to remain stable and functional without a traditional foundation, the floor itself must carry structural duty and also be capable of self-leveling against uneven ground. In the Tesla tiny house, The floor is realized as a revolutionary floating base. A perfectly flat, engineered platform that simply rests on the ground rather than being permanently anchored into deep footings. It combines a carbon composite honeycomb frame with strategically cross-oriented compression layers to evenly spread the load across the entire area. This honeycomb approach closely mirrors the sophisticated panels used in aerospace applications, such as airplane wings and rocket structures, where each individual cell acts like a tiny column, sharing weight across the whole surface. When an owner walks or places a heavy appliance, forces do not spike at a single point, but are instead smoothly distributed, which keeps the floor incredibly stable and highly resistant to local settlement. Even on imperfect or slightly soft ground, carbon composite earns its place because it is exceptionally light yet incredibly strong in both compression and bending. Compared with a traditional concrete slab, it weighs only roughly 1/4 as much, yet offers a significantly higher elastic modulus. As a result, the panel can easily handle about 300 to 400 kg per square meter of live load without any noticeable deflection or movement. The frame is modular and hollow, incorporating a foam core for enhanced sound dampening and thermal buffering. At the crucial ground contact point, the platform sits on engineered rubber or stiff composite pads that both prevent sliding in strong winds and effectively block ground moisture from wicking up. This clever design unlocks site setups on a wide variety of terrains, from sand and gravel to grass and forest soil. Crucially, no excavation or concrete pour is required, which are typically the most time-consuming and expensive components of any traditional building project. With this method, the Tesla tiny house can sit comfortably on a roughly leveled patch of ground, perfectly fulfilling the free land spirit. Because the owner does not permanently alter the soil structure, moving later leaves behind no unsightly pits or leftover concrete debris, naturally returning the site close to its original state. The floor is also meticulously designed for rapid assembly. Factory-built modules arrive with keyed grooves and pre-marked bolt points. On site, just 2 people using basic hand tools can join the entire floor frame together in roughly 4 hours. There is no need for heavy equipment and no requirement for specialized, expensive crews. You simply perform a rough flatness check and follow the clearly marked sequence. Once fully tightened, the floor instantly becomes the structurally sound base for the walls and the roof above. 5 closed, loop air and water system to live completely apart from conventional urban infrastructure. The Tesla tiny house requires water and air systems that are self-sustaining and function without tying into municipal lines. The clever solution is a closed loop of capture, advanced filtration, use, and regeneration that fully supports a 2-person lifestyle with absolutely no external hookups. It begins with an efficient rain capture system integrated into the roof. The energy roof has a special coating that allows water to shed quickly without retaining dirt or debris. Collected water is routed to a hidden underfloor tank through a coarse pre-filter. It then passes through a sophisticated 4-stage reverse osmosis, a row-style setup, a mechanical screen, an activated carbon layer, a nanomembrane, and finally, a powerful UV sterilizer. The final result is water that is clean enough for all cooking, washing, and showering needs. With the average annual rainfall around 400 mm in many western U.S. states, this system can reliably supply about 50 liters per day for a 2-person household under typical conditions, effectively covering all essentials without needing an external well or main line. After use, gray water from sinks and showers is not simply wasted. It enters a unique bioreactor that uses nano-carbon media. Beneficial microbes colonize the surface and effectively break down organic matter, while the carbon reduces odor and captures any heavy metals. The output is water that is clear enough for reuse in irrigation or outdoor cleaning. With this intelligent loop, daily water loss can be reduced to roughly 10 to 15% of the intake, keeping the system stable for long stretches without requiring frequent external top-ups. In parallel, the air system is expertly balanced. The home's air conditioning's AC unit is seamlessly paired with a heat exchanger module that recovers thermal energy the AC would normally simply dump. During cooling, excess heat is routed to preheat domestic water or warm the incoming morning air, saving about 30% electricity compared with typical residential AC units. In colder conditions, the module scavenges heat generated by internal devices and solar warmth from the roof to temper the incoming fresh air supply. 6. Fire and moisture-resistant industrial interiors. If you are now ready to make the dream of free land living a practical reality, please subscribe to AutoFusion. Help us reach our goal of 8,370 subscribers and be sure to turn on the notification bell today.